Trigonometrics, and we are on chapter 3, Kinematics of Linear Motion, and I will be doing equation of motion. This is lesson 6, okay? So I'll just derive 3 equations of motion today. Let's take the first equation of motion. First equation of motion is Vf is equals to Vi plus At. I will prove this, okay, and let's see how it goes. Well, the proof, we know that, let's suppose Vi to be the initial velocity and Vf to be the final velocity. So when I say that the change in velocity, let's say delta V is equals to change in velocity. So when a car is moving with an initial velocity of 20 meters per second and then it retains a velocity of 40 meters per second, so the change will be 40 minus 20. So let's say the change in velocity del V is equals to Vf minus Vi. Okay, there we are. Let's call this the first equation. Now we know, according to the definition of acceleration, if A is the acceleration, so acceleration is defined as the rate of change in velocity. When I say the rate, it means per time. So the change in velocity upon time taken. This is what acceleration is defined as, the rate of change in velocity. Now I'll substitute the equation, the value of del V from equation 1 in this equation, which is equation 2. So I'll get A is equals to, now I'm replacing del V with Vf minus Vi. So this will become Vf minus Vi upon T. Okay? And by cross multiplication, I will get Vf minus Vi is equals to At. If I shift del V minus Vi, that is the initial velocity, on the other side the sign will change. So Vf is equals to Vi plus At. Hence, we have just proved that Vf is equals to Vi plus At. Okay, let's move on to the next equation, the second equation of motion. Second equation of motion. Now, the second equation of motion, we will prove, what we need to do is we need to prove that S is equals to Vit plus half At squared. This is what we are going to prove. So I'll start the derivation over here. Proof. Now we know that average velocity. Okay. Let's say the average velocity is V dash. So this is equals to distance upon time. Okay, we know that. So now let's cross multiply. So we'll get S is equals to V dash times T. And we know that, let's call this equation number 1. We know that average velocity, when you consider two velocities, Vi and Vf, so we can say the sum of the two velocity divided by time will give you the average velocity. Now I'm substituting this value of average velocity in the first equation. So I will get S is equals to, instead of writing V dash, the average velocity, I'll put Vi plus Vf upon 2 times T. Okay, there you are. Now, we know that Vf, since Vf is equals to Vi plus At, because we don't require Vf over here, final velocity, we just require initial velocity. So I need to get rid of this final velocity. So according to the first equation of motion, we just proved that Vf is equals to Vi plus At. So what I'm going to do now, I'm going to replace this value of Vf in this equation. Okay? So my equation will now be S is equals to Vi plus, instead of Vf, I'm going to put the value that Vi plus At. Okay? Over 2 times T. So now my equation will be S is equals to Vi plus Vi will give you 2Vi plus At over 2 times T. Okay, let's take this 2 or let's leave it this 2 over here because we need to find the value of s. Okay, so I can multiply this t with 2vi, so I'll get 2vit, and if I multiply it with 80, I'll get at squared. Over 2 means I can write it down this way. Okay, so this 2 and 2 would cancel, so I got s is equals to, this can be known as vit plus half at squared. Okay, 80 squared upon 2 means half 80 squared. Hence, I've just proved the second equation of motion, which is s is equals to vit plus half 80 squared. Okay, now let's move on to the third equation of motion. Excuse me, I'll just quickly do it over here. Now I'll prove the third equation of motion, and the third equation of motion is 2as is equals to vf squared minus vi squared. This is the third equation of motion. So, we know that vi is the initial velocity, vf is the final velocity, a is the acceleration, and t is the time taken. Okay, and let's move it over here. Okay. Now, just like how we started off with the equation of motion, I'll just do it the same way. But we know that the average velocity is distance upon time, because we have distance also, s over here. S is your distance. So, cross multiply, we'll get s is equals to average velocity into time, and average velocity, you know, is equals to initial plus final upon 2. So I'll replace this value in this equation. I'll get s is equals to vi plus vf upon 2 times t. Now in this equation, we do not have time. We have to get rid of this time. Okay. So what do I do now? I know that according to the first equation of motion, which I just proved, that vf is equals to vi plus at. Okay. Let me call this equation 1, and from here I'll get the value of time. I'll replace this vi over here. I'll get vf minus vi is equals to at. Move acceleration on the other side. Time is equals to vf minus vi upon a. Now all I need to do is I need to replace the value of time from the second equation in equation number 1. So my equation will now be s is equals to vi plus vf upon 2 times, in place of t I can put the value, that is vf minus vi upon a. Now this is in the form of a plus b into a minus b. As you can see over here, vf plus vi upon 2, I can write it in this way, and vf minus vi upon a. So if I take this 2 and this is vf plus vi and vf minus vi. So vf plus vi and vf minus vi, 2 times a will give you 2a equals to s. Let me take this 2a here, and you know that this is in the form of a plus b into a minus b. So this will give you a squared minus b squared, difference of 2 squares. So I can take this 2a here, it will become 2as, and this of course in this form it can be written as vf squared minus vi squared. Hence, the third equation of motion, 2as is equals to vf squared minus vi squared. Okay, I hope it's clear to you all. Thank you very much. Hope to see you in the next lesson. Take care.